Hello students, welcome to Sreenath. Today we are going to discuss a chapter. The chapter name is Force and Pressure from a CBSE 8th Standard Science Subject Chapter 11. Okay, from CBSE syllabus, from 8th Standard, from Science book. We are discussing Chapter 11, that is nothing but Force and Pressure. What is the chapter name? That is Force and Pressure. In this chapter, Force and Pressure. In this chapter, how many topics we are having? In this chapter, we are having 10 topics. How many topics? 10 topics. Okay. Oh, 10 topics. It is a very big chapter. Don't feel like that. It is a very easy chapter, and I will explain all the 10 topics in very short time and with very simple, easy examples, so that you can remember all these 10 topics. You can understand all these 10 topics, all these concepts in your mind with practical examples. Okay, so before starting the session, give me a like. Don't forget to subscribe our channel for more videos, and we will start our video now. Before going to start our whole chapter, first we will see what are those 10 topics, and after that we will discuss each topic in detail. Okay, now we are going to discuss 10 topics overview. Okay, now first topic is force. What is meant by force? Force, a push or pull. That is the first topic we are having. The second topic, forces are due to an interaction. Then what is the third topic? Third topic is exploring forces. Then what is the fourth topic? Fourth topic is a force can change the state of motion. Fifth topic is force can change the shape of an object. Now sixth topic is contact forces. In the contact forces we have subtopic, that is muscular force, and friction is the another subtopic in the contact forces. The seventh topic is non-contact forces. The eighth topic is pressure. Ninth topic is pressure exerted by liquids and gases. 10th topic is atmospheric pressure. Okay, we have 10 topics, and we will explain and we will discuss each and every topic in detail within less time. Okay, so that you can learn more topics in less time, then you will save your time. Okay, now we will start with the first topic. First topic, that is force. What is meant by force? If anybody asks you what is meant by force, force is nothing but a push or pull. A push or pull. Force is nothing but a push or pull. Do you know the meaning of push? Yeah. Do you know more meaning of push? Yeah, we are pushing. What is pulling? Pulling means simply what is meant by push means, pushing means if you are moving anything away from us, that is called pushing. If we moving anything towards us, that is called pushing. Suppose here is a bag or table or any object. If you here, you are there, it is you, it is the bag. If you move this bag away from you, then that is called push. If you take this, if you move this bag towards you, it is called pull. Pull means if the moving some objects or anything towards you is called pull. Moving some objects away from you is called push. So force is nothing but a push or pull. See these images. This is the goalkeeper. What he is trying to do? He is trying to stop the ball. Okay. What he is the hockey player. What he is doing? He is applying some force and changing the direction of that ball. What he is doing? Basically, what he is doing? He is applying some force, which means he is pushing it. He is pushing that ball. Okay, he is stopping that ball. He is also tries to stopping that ball. So what is meant by force? Force is nothing but a push or pull. In so many incidents in our daily life, we come across this push or pull. Okay, I will give you some examples. Okay, picking. Do you know what is meant by picking? Opening, shutting, kicking, hitting, lifting. Now we will write Picking. What is meant by picking? If there are bucket in a bucket or in a basket, there are so many of mangoes. What you will do? You have to pick one mango. You have to pick one mango. One mango. Picking is nothing but pull. Why pull? You are taking one mango from the basket and you are moving that mango towards you. Towards you means pulling. And next means opening. Opening a door. Suppose a door is there. How you will open? A door is there. How you will open? You took the handle and you drag the door to open like this, which means towards you, which is also pull. Next, shutting means closing the door. If door is like this, what you will do? You apply some force, which means you are shutting it, closing it. That is moving away from you. Means pushing, which is nothing but pushing. So push. Whenever you push, while closing you are push. Okay. Next, kicking. We will kick the ball, no? Next, hitting. We will hit the ball using a bat. It is also moving away from us. It is also pushing. So finally, what I am trying to sell is the actions like picking, opening, closing, kicking, hitting, and lifting, flicking. All these come under push or pull. In all these actions, whether we are pushing something or pulling something, so that push or pull is called force. What we are calling force means we are pushing something and we are pulling something. So this push or pull is called force. Force is nothing but push or pull. We are daily doing so many activities, so many things. In all those actions, we can categorize all those actions into push or pull, and that push or pull is nothing but force. I think now you can understand what is meant by force. Force is nothing but a push or pull. In doing so many actions like picking, opening, closing, kicking, in all these actions, what will we do? We will push or pull. That push or pull is called force. That's itself. So what is meant by force? Force is nothing but a push or pull. Okay, a push or pull on an object is called a force. Yeah, finally we have learned about force. Then first topic is completed. How many topics we have? Remaining 9 topics. Okay, the second topic. Basically, what is meant by force? Force is nothing but a push or pull. We have understood it. Now, forces are due to an interaction. Let's give me an example. Here there is a car and there is a man. Does this car moves forward due to presence of him? He is there, he is standing there, he is not pushing or pulling. Due to the presence of him, does this car moves? No. After that, what he is doing? After that, he is touching the car, and he is interacting with the car. And he is pushing the car. Does the car moves? Yes, does the car moves. Why? In this case, he is not touching the car, he is not interacting with the car. That's why it is not moving. But in this case, he is touching the car, he is interacting with the car, so that he is pushing it, so that here it is moved, so that here he applied some pushing force. In this figure, 2 girls are there, whether they are pushing or pulling. In this case, 2 girls is there, whether they are pushing or pulling, or who is pushing whose. In this case, one animal and boy is there, whether they 2 are pulling or pushing. Yeah, finally what we can say, in this image, both girls are pushing each other. She is pushing her, she is pushing her. In this image, she is pulling her, she is pulling her. In this image also, the man is pulling the cow and the cow is pulling the man. Finally, what we can say that force act only when two or more objects interact. What is the word called? Interact. Force acts only when two or more objects interact. Where there is an interaction, there is a force. Force is basically due to an interaction. Here there is no interaction between the car and the man, but here there is an interaction between the car and the man. So here pushing is done, here force is applied. Here no pushing is there, no force is applied. So what we can understand, for every force, in order to observe force, we must need an interaction. Without interaction, there is no force. What is that? Without interaction, there is no force. So forces are due to an interaction. Whenever there is an interaction, there is force. Here there is an interaction between these two girls. Here there is an interaction between this boy and cow. Here there is an interaction between these two girls. Here there is an interaction between the car and the man. But here there is no interaction between the car and the man. So there is no force. Finally, what we have understood, that forces due to interaction only. At least two objects must interact for a force to come into play. In order to see a force, at least two objects must interact. Then only force will come. We have completed two topics. Now we turn to third topic. What is the third topic? Third topic is exploring forces. Okay. We have understood what is meant by force. Force is nothing but push or pull. And what next? We have understood that in order to force come into play, in order to observe the force, there must at least two objects are required, and the two objects must interact each other and must interact with each other, so that only force will come. So if you want to see force, you have to push or pull. That is the first condition that is meant by force. And the second condition is at least two objects must interact like pushing or pulling, so that only force will come. Now third topic is exploring forces. Now just see this image. In this image, two boys are there pushing this big box from one direction. Before this, try this at your home. Take some huge box or huge weight that you cannot move. Basically, if you only tries to push that box or that weight, you cannot do it. Select that type of box. That type of box must have large weight such that you cannot push it or you cannot pull it. First try to push it. If you can't push it, then ask for another guy to help you. Try like that, another guy to help you, like this. This is a large box. Two boys are trying to push it. Does it move? Yes, it will move. In the previous case, what happens? Single boy is pushing it, but it is not moving. In this case, two boys are come and try to pushing it. It is moving. The third case, first case, single boy. Second case, two boys, same direction. Third case, two boys, opposite direction. Just listen. First case, single boy pushing, it doesn't move. Second case, two boys are trying in the same direction, it is moved. Third case, what will happen? In the third case, two boys are moving, applying force in the opposite direction. He is moving this direction, he is moving in this direction. They are opposite to each other. Does this block moves? Finally, this box does not moves. Why? Because why it means, what we can understand, in the first case it does not move, but in the second case it is moved. For suppose we have taken two boys, so the F1 is the force applied by the first boy. That when he applied the force F1, it does not move, but And in the second case, what happens? Two boys are pushing. So first boy applied force is F1. The force of the second boy is F2. So these two boys are try to move that box in the same direction. So what happened? It is moved. In the third case, two boys are trying to move the box, but it does not move. The first boy is applied force F1. F1 is the force applied by the first boy. F2 is the force applied by the second boy. It does not move. In this case, I have represented plus here, I have represented minus here. Why means, in this case both forces are acting in one direction, so I have added both the forces. Then only basically due to that reason that block has moved. But in the second cases, there are two forces. These two forces are acting on the box. These two forces act. This is the F1 force. This is the F2 force. They are acting in the opposite direction. F1 force plus F12. They are acting in the same direction. What is the difference in these two directions? In this image, both are applying force in the same direction, so that it is moved. But in this diagram, they are moving in the opposite directions, so that it can't move. Finally, what we can understand that if you apply forces applied on an object in the same direction, add what will happen? If you apply forces in the same direction, those forces will add up. Here what we have seen here. But forces applied in opposite direction. If the two forces acting in opposite direction on an object, the net force acting on it is the difference between the two forces. Here is the two persons trying to pushing it, but but the resultant force is difference of these two forces. That is, in this case, that is F1 minus F2, but in this case it is F1 plus F2. Why F1 plus F2 means they are applying the force in the same direction, so that's why we are adding that force. But in this direction they are applying force in the opposite direction, that's why we are subtracting it. Okay, subtracting it. We have practically seen that when two forces are acting in the same direction, it is moving. When objects will move, if we apply the force required to overcome the friction, you will learn about friction in the later classes. If you apply force on the objects, then it will move. If you apply the force greater than the weight of that object, then it will move. Otherwise, it won't. But in this case, it doesn't move. Why means these forces are acting in opposite directions. You have played this game of tug of war. What happens in this game? There are three boys here. There are three members here, three members here. They are trying to applying force, and these are pulling. These members are pulling these members, and at the same time these members are pulling these members. By this activity, what happened? The rope remains constant. No one will come to the another one. I think you have played many times. If you played this game, give me a like and comment below, so that I can know you have played that game. Okay, now if another person added here, what will the situation? If another person added here, what will the situation? The situation means nothing but then all these members will come into this side. Why? Because the force is adding up. Three boys is pulling. Now fourth boy is coming up and the fourth force is coming up, so fourth forces are greater than the three forces, so the rope will come to this side. If we add another person to this side, they will again get into the equilibrium position. No one will fall. If you add another person to this side, then five persons are there, and what happens? The rope will come to this side and these fellows will fall into this side. Why? Because because there are 5 members, 5 forces acting on this side, 5 forces trying to pulling. This force is greater than this force, so difference of force will get this side. Okay, so finally this we can understood. One simple thing, students, don't confuse. If you forces add up in same direction, forces subtract in opposite direction. In which direction? Opposite direction. Okay, if you apply force in same direction, they will add up. If you apply force in opposite direction, they will subtract. The resultant force is, what is the resultant force is, in this case F1 minus F2. Resultant force in this case. What is the resultant force in this case? Resultant force F equal to F1 plus F2. We are adding both two forces in the case of which case? In which case of same direction. We are separating the forces in the case of opposite direction. That is the exploring forces. We have completed 3 topics. What is meant by force? Force is nothing but push or pull. Then and what is the second topic? Forces always need an interaction. If there is interaction between 2 objects, at least 2 objects, then only force will occur. We need 2 objects, they have to interact, they have to push or pull, so that only force will occur. And then what next? The third topic is nothing but if forces acting in the same direction, they will add up, or if the forces acting in the opposite direction, they will subtract. That is the third topic. Now fourth topic is what force can do. Force can change state of motion. Okay, what force can do? Force can change state of motion. Okay, I will give you an example. Suppose in the cricket, or suppose in the football. Okay, this is the football. This is at rest position. His velocity is 0. It is in the rest position. What happened next? One player coming and kicked this ball. What he has done? Kicked this ball. What happens to this ball? This ball moves. It starts moving with some velocity, some 10 kilometers per hour, or like that. Whatever the velocity, that is just don't bother about it. Okay, initially it is in rest. But after he kicked it, it get into the motion. Kicking means nothing but pushing. Okay, he pushed this ball. So what happened in this situation? Whenever we kick, whenever we apply push, whenever we kick or whenever we apply push, the ball which is in rest position is moving, which means nothing but. Now what is meant by state of motion? State of motion means whether your state is rest or whether your state is motion. If rest means nothing but you can't more explanation about rest. We know rest position. If your velocity is 0, if you are not moving with respect to the surroundings, with respect to the ground, then you are in rest position. Then motion position is if you are moving with some velocity or some acceleration, then you are in the state of motion. What happened? Before kicking, the ball is in the rest position, but after kicking, the ball is in the state of motion. It is in the state of moving. So what we can finally conclude? Students, that is nothing but force can change state of motion. After kicking the ball, its state changed from rest to motion. So what we can conclude that force can change the state of motion. Suppose here is the example. Here is the tire. We have played this game in our olden days or in our childhood days. I think you may play these games. Whenever at the beginning it is in the rest, but when you take this stick and start applying and start pushing it, what happens to it? It will start moving. So what you are doing, you have pushed it. Pushing is nothing but force, which means you applied force, you have applied the force. For that reason that due to that force, its state is changed from rest to motion. Previously it is in the rest motion, now it is in the moving state. Finally, what I will tell to you, force changes state of motion. What is the example for it? The example for is football. Previously the ball is on the ground, it is in the rest position. When the player come and kicked it, it moves with a high speed. It is in the state of motion. Previously it is in the rest state, but after it is in the state of motion. So what happened here? Its state is changed. Why its state is changed? Because the player applied the force, because the player kicked it, because the player pushed it, because the player applied the force. That what we can observe from this means force can change the state of motion. That is the example I have given. 4 topics are completed. Okay, in all these examples, the speed and the direction of a moving ball changed with the application of a force. Can you give a few more examples of this kind? Can you give other examples like this? Okay, some other experiment is there. A ball is coming in this direction. A ball is coming in this direction. If you stop it using a scale with some angle, what happens? It will comes and strike it and changes direction and moves into this area. Finally, what is the state of motion? Here its direction is changed. In the previous football example, what is changed? Its velocity is changed, its speed is changed. Basically, remember one thing, in the football example, its speed is changed. In this example, its direction is changed. What is meant by state of motion? The state of motion of an object is described by its speed and the direction of the motion. State of motion is nothing but described by its speed and direction. If speed changes, then we will say that state of motion is changed. If direction changed, then we will say state of motion is changed. Basically, what we are saying that if your speed changes, state of motion is changed. Otherwise, if direction changes, state of motion is changed. In football example, speed is changed by kicking it, by pushing it. Pushing is nothing but force. What we can say? By applying a force on a football, its speed is changed. So finally, what we can say? Force changed the speed, force changed the state of motion. Okay, in this scale experiment, what has done? By applying the force, here does we applied any force? Yes, we have applied the force. That is with the help of a scale, we have applied some force. I will give you the example. If there is a small ball here, if there is a large ball here, suppose it is coming with some velocity or some speed, that is 10 kilometers per hour, like that, or some any speed is coming very spot. If this ball is at rest, what it will comes and collide with it. What happened? After some time, after collision, this ball also will start moving. But in this question, ball is coming. Here we place it scale. If it comes and strikes, what will happen in the according to this condition? This scale also must move, but it is not moving. Why? Because we applying some force on this scale. In other words, we applying this force on scale. In other words, scale is applying the force on this strong ball. Scale is applying the force on this strong ball. That's for that reason it after striking it, after collision with it, changed direction and moved in this direction. So basically, don't think we have just placed the scale, we didn't apply any force, but how direction changed? don't think like that. Here we are here we are used scale, which means we are applying force on the scale. That for that reason only it does not moving. Otherwise, if you didn't apply force on it like this in this example, this ball moves as it likes, the scale also moves. But we are applied force on the scale, that's why the scale is not moving. In turn, the scale is applying force on this large ball. For that reason, it changes its direction and moves in another way. From scale experiment, what we can do, direction is changed by the application of force. So finally, what can we say? Force changed the speed. Force changed the speed. Force changed the direction. Finally, force changed the state of motion. State of motion is nothing but speed and direction, depends on speed and direction. If speed changed, we say state of motion is changed. If direction changed, we say state of motion is changed. By applying force, both these are changed, so state of motion is changed. That is the fourth topic we have completed. Now fifth topic. Fifth topic is nothing but force can change the shape of an object. Force can also change the shape of an object. Example is there. Suppose this is the what it is. This is the duff on a plate. Wheat duff or anything. If you apply force using these hands, what will you observe? The shape of that will change. Another example is while preparing chapatis. First you prepare round balls. After you use to make circular shape chapatis. Previously it is in the spherical shape, after that it is in the circular shape. How you are changed this shape? By using roti maker stick. We apply a roti maker stick and we are applying force. By the application of force on roti stick, you changed the shape. At the same time, if you are sitting on a cycle whose seat has having springs, when you sit on it, what happens? The springs will compress. Another example is there is a nail. If you hang rubber band to this nail and try to pluck it, previously it is like that. It is the nail. When you pluck its shape, previously its shape is here. Now its shape is here. Its shape is changed by the application of force. That finally, what we can conclude, that force can change shape of an object. Force can change shape of an object. Another example is if you inflate balloon. If there is a balloon, if you press it with your hands, what happens? It will depress like that. Its shape will change when you apply pressure on it, pressing it. Okay, these are the examples that force can change shape of an object. We have completed 5 topics. Now sixth topic, that is contact forces. Contact forces. In contact forces, we have some subtopics. That is, first subtopic is muscular forces. Second subtopic is friction. Okay, muscular force. Okay, we will find the definition for it. Here, this force is caused by the action of muscles in our body. The force resulting due to the action of muscles is known as muscular force. What is muscular force? Muscular force is nothing but the force which is also a force resulting due to, for which reason it is coming? Due to the action of muscles. Due to the action of our muscles, if a force exerts, that is called muscular force. Suppose, for example, it is the pen here. What I am doing? I am picking it and moving towards me. What I am doing? I am pulling it. Pulling means force. Here, what is it for? What does this force means? What does this force? That is muscular force. Why muscular force? Means here I am pulling. Pulling means there must be a force. Then what is that force? That force is muscular force. Why? Because means in order to pull this, how I am getting force. My muscles, due to the action of muscles, I am pulling it. In our day-to-day life, we will do many activities. whether we have to pull or push or to walk or to stand, for any activities we need some energy, and we will our muscles will act, and our muscles will, if you want to pull anything, pen or bag or anything, if you have to push or anything, for any purpose, for anything, we always need use our muscular forces. Due to the action of our muscles giving the helps us to show that force. Our muscles give helps us to give that force. Okay, basically what is meant by muscular force is force due to the action of muscles. Force due to the action of muscles is called muscular force. Basically you have seen this image. These are cows carrying heavy weights. Basically what we are using here we are using the muscular force of cows to drag or to move these heavy weights. We are using muscular force of cows to carry heavy weights. At the same time, we use our muscular force to pull or push. So what is meant by muscular force? The force coming due to the action of our muscles is called muscular force. That's itself. The force which is coming due to the action of our muscles is called muscular force. Okay. Next, what is meant by contact force? Basically, I am pulling this or pushing this, whether I am touching it or not. I am touching it. Without touching, I can get it. No, I am touching it and pulling it. So there is a contact. I am touching, which means there is a contact. Without contact, I couldn't apply force on it. So what force requires? Force requires two interacting objects or two interacting things. What are the interacting things in this example? I am one body and this is the another body. I am the interaction between me and this object is called force. I am pulling it. Interaction is there and I am pulling it. Pulling is called force. And how I am pulling? I am touched it and dragged it. I touched it and dragged it. I contacted it. I and this pen have contact. So that what this force is called? Contact force. Why? We are applying we are touching it. By touching it, we are applying force. So by contacting it, we are applying force. For that reason, it is called contact force. Contact force is nothing but when applying push or pull, when applying force, if you are in the contact, if two interacting objects are in contact, then it is called contact force. Then what is meant by non-contact force? If there is no contact between the two interacting objects, then it is called non-contact force. Okay, one of the contact force is muscular force. In order to apply muscular force on any object to pull or push, we always need a contact. Without contact, we can't apply the force. So muscular force is a contact force. The second thing is frictional force. We will learn more about friction in the next class, but for our convenience, but now we will talk about it little. Okay, what is meant by friction? Okay, friction always acts in opposite direction. Friction always acts in opposite direction to the moving objects. Friction always opposes the motion. Friction always opposes the motion. Okay, friction always acts in the opposite direction to the motion. Okay, there is a ball and you kicked the ball. Football player kicked the ball. What happens? It starts its journey and goes on. It increases its velocity and finally it stopped. Before he kicked, it is in the state of rest. After he kicked, it is in the state of motion. But eventually, finally, it is in the state of rest. What previously we have learned? When does a state change? Whenever we apply a force, its state will change. Whenever we apply a force, its state will change. Here, its state is changing from rest to motion. Why? We are applying force. In which form? We are kicked the ball. So we have applied some muscular forces, we have applied some contact forces. So for that reason, it has changed its state from rest to motion. But after that, we didn't apply any force. But the body which is in motion is drop out to rest position. It again changes its state of motion. why why it's changed its state of motion. We previously know that what we have previously discussed. In order to change the state of motion, we must require a force. In order to change state of motion, we must require a force. Basically here we used the force, muscular force to kick the ball. But here also state is changed. But here we didn't apply any force. But why it stopped? Which means there is some other force which is acting on this. So with the whenever there is a force, then only its state of motion will change. Here state of motion is changed, so that there must be a force. What is that force? That force is called friction. Frictional force will always act in the opposite direction to the moving objects. It is moving in this direction, friction is acting in the opposite direction. And friction is a contact force, where it always acts in between the two surfaces. Here what is the two surfaces? One is the ball and the another one is the ground. Here one is the ball, first one is the ball, second one is the ground. Okay, so friction must always act in between two surfaces, and friction always act in the opposite direction to the motion. Friction always tries to stop the motion. Okay, this is about friction. This is also contact force. If there is this force will occur, this force will come into play only when there is a contact between two surfaces. If there is no contact between two surfaces, no friction. So friction is a contact force. Now we have completed 6 topics. Now we are going to discuss 7th topic, that is nothing but non-contact forces. 7th topic is non-contact forces. Previously we have seen contact forces. Two interact objects must in contact, so that if two interacting objects are in contact and the force come into play, then it is called contact forces. If two interacting objects are not in contact also, but there is a force come into play, then we call it as non-contact forces. Okay, even though there is no contact between the two interacting objects, in that condition also, if force come into play, then we call it as non-contact forces. When there is a contact, then only the force come into play between the interacting objects, we call it as contact forces. Okay, in non-contact forces we have 3 examples, 3 subtopics. There is 3 topics, that is first one is magnetic force, next one is electrostatic force, and next one is gravitational force. What is meant by magnetic force? We have previously learned opposite poles of a magnet attract each other, same poles of magnet repel each other. Just do this experiment. Here is one magnet, we are taking another magnet. This is some pole, this is opposite pole. What opposite pole? When we tries to take this magnet to the one pole of this magnet to the other pole of this magnet, what happens? It is moving away. You will find some distance. Previously it is here, but it has moved to this distance. But what happened? Why they are moving? It is pushed away. Why it is pushed away? Whether we have applied any force, whether we have touched this magnet, no, we didn't touch this magnet with this magnet. But why it is moving? Why we are seeing some pushing effect? Because there is some force. That force is called magnetic force. Where there is a push or pull, there must be a force. Here we are seeing some push. Here we are observing some push, so there must be a force. That force is called as magnetic force. One great thing here is we are not interacting, we are not touching it, we are not in contact with the two interact. There is no contact between the two interacting objects. Even though there is no contact between the two interacting objects, we are seeing some pushing effect. So there is whenever there is a pushing effect, there is a force. So even though there is no contact, we are observing the pushing effect, we are observing the force. For that reason we called it non-contact forces. And here what is the force which is pushing is magnetic forces. So magnetic force is a contact forces, non-contact force. Next topic is electrostatic force. What electrostatic force is? Take two halves, take a straw and cut it into two pieces. Tie one straw to a table like that and take another straw. Rub that straw with piece of paper. This another straw is rubbed with paper. We have to rub the straw with paper. You have to like rub. You have to rub the paper with straw, and we draw near. If you take that straw near to the straw, what happens? The straw try to attract it. What happens here? Why it is attracting? We are seeing some pushing effect. Sorry, we are seeing some pulling effect. The straw who is hanging is coming towards the straw which is in hand, but we are not touching these two straws. But why it happening? We are seeing some pulling effect. Where there is a pulling effect, there is a force. But what is the force? The force is electrostatic force. And one thing is, we are not touching. There is no touching effect. There is no contact. So this is called non-contact force. And here is the force is called electrostatic force. Why electrostatic force means? When we have rubbed this with the paper, it becomes charged. So basically what happens? Charged body attracts non-charged body attracts. So what happened? This charged body pulled the other non-charged body. Okay, but we are not in contact. So this is the non-contact force, and this force is called electrostatic force. Okay, finally gravitational force. We have seen this force many times. When we throw an object into sky, it will fall down to the earth. When we throw your pen or any object into the sky, after reaching some maximum height, it's starting coming towards earth. But who is pulling it? Is there any force? We are not applying any force. But in order to go high, we have applied some force. That's why we are pushing it. Due to the reason of our force, due to our pushing effect, it is goes to up, but reaches maximum and stopped here. And after that, it is coming towards down earth. Why? Who is pulled here? But it is, we are seeing some. It is like one is pulling down. We have observed the pulling effect. Where there is a pull, there must be a force. What is that force? That force is gravitational force. Earth is exerting the force. The interaction between the earth and the objects, and there is no contact between the earth and objects, but there is a pulling effect. So it is a non-contact force, and this is due to the earth gravitational force effect. So it is called gravitational force. Finally, we have done with this also. So we have completed 7 topics. We have 3 topics remaining. 8th topic is pressure. What is meant by pressure? Okay, pressure is nothing but force per unit area. For example, pressure is nothing but force per unit area. Basically, you have seen these boys on the railway station. We call those as porters. What they will do while carrying heavy weights on their head? What they will do? They have a red towel and they will round it around their hair. They will make around their head. They will make round like that. Around their hair, they will around their head. They will tie. Around their head, they will tie around their head this cloth, red cloth, and put heavy weights. If this is the not scenario, if this is the head, if they tied whole cloth at the one point and try to carry heavy weight, what happen? Just think, or just do it with little weights. What will happen here? Total force which is acting on his due to weight is distributed overall the surface in larger area in overall head, but total force, same force is acting, but that force is constrained to single point only. That whole force is acting in single point only. What happens here? There is large pressure. He feels very pain at the head. Suppose it is the head, face, he feels that point, he feels there is very large pain. Why? Because means whole weight is acting, whole force is acting at single point, but here whole weight is acting uniformly over the head, which means the whole force is equally distributed among total head. So that whole pressure, that pressure, this is called pressure. In this case has less pressure, in this case he has high pressure. Pressure is nothing but force per unit area. If you have more area, pressure is less. If you have less area, pressure is more. Here more area, so pressure is less. Here less area, so pressure is high. So pressure is nothing but force per unit area. Until now we have studied about the force. If you apply force in specific point area, then pressure will be high. If you apply force in the large area, pressure will be low. Okay, and the units of pressure, we will study about the units also. That is called pressure. Now we will study ninth topic, pressure exerted by liquids and gases. Pressure exerted by liquids and gases. As liquids and gases have pressure, we will find out it with an example. Take a long pipe like this and tie at the end a rubber, a strong quality rubber, tie a quality rubber at the end. Start pouring water in it. At this height, it has bulge out some amount. If the water is increased, the bulge out is increased. There is a large bulge out at the end. What does it mean? Basically, it is the liquid which is pushing it, which is the reason for bulge out. Is the liquid is increased, so that bulge out is increased, which means liquid exerting force, liquid exerting pressure. This is bulging out, this is expanding, this is pushed by water. So when there is a push, there is a force, and this is acting in this particular area. Force per particular area is nothing but pressure. So does liquids has pressure? Yes, liquids has pressure. Liquids has pressure. If you tie a same balloon or any rubber, as in this picture, what happens? If you start increasing the water level, the balloon will bulge out. The rubber sheet will bulge out. What is the reason? What is the reason for bulge out? Means those liquids are exerting force on the walls of the rubber, and due to that forces, it bulging out. It is elasticity comes into play. They are stretching. Why they are stretching? Because they have feeling some push effect. The push effect is due to the force. What is the force? Force per unit area. That is due to the pressure of the liquid amount. And if you take another plastic bottle, if you make holes with same diameter at the same height, what will you observe? When you pour water, what will you observe? All will flow in same streamline, all will fall at the same distance from the bottle, which means that pressure is same at depth, at all points in a depth, in a depth, at all points in same height. What does it mean? Which means, suppose this is the bottle at this height, all points, whatever the points in this height have same pressure. Whatever the points or whatever the particles in this height have same pressure, have some pressure, that is P1, that is P2, and whatever the points at this height have some another pressure, P3 and P3. Okay, what does it finally means? Means pressure is same at all points in the same height. Pressure is depending upon the height. At the same height, all points have same pressure. Finally, liquids exert pressure on the walls of the container. Container. For that reason only they are bulging out. So we have completed 9th topic also. We are coming into the 10th topic. What is meant by atmospheric pressure? Atmospheric pressure. Basically, what is meant by atmosphere? There is what is meant by atmosphere means, and the envelope of air is known as the atmosphere. Okay, on earth there is large air molecules. There is air above earth up to some kilometers around earth, around on the surface of earth up to some kilometers there are large air molecules. These envelope of air, envelope of air called atmosphere, we called it as atmosphere. And the pressure exerted by the molecules in that atmosphere, pressure exerted by air molecules in atmosphere is called atmospheric pressure, atmospheric pressure. We call it as atmospheric pressure. What is meant by atmospheric pressure? Which is nothing but the pressure exerted by the air molecules in the pressure exerted by the atmosphere is called atmospheric pressure. Okay, now what is meant by atmospheric pressure in a mathematical form? If you want that, take an unit area like that, take an unit area, the molecules in unit area exert the force on that unit area. That force per unit area is called the atmospheric pressure. If you want to know how much is atmospheric pressure, take a rubber lid like this, take a small rubber cup or rubber sucker like this, and try to push it to the ground, so that the air in between the lid and the ground must be full out, so that no air is in between the ground and the rubber sucker. Now try to pull it. If you can, no man can does it due to this large area. Now if you try to pull it, you can know how much atmospheric pressure is. Why? Because over this surface there are large number of air molecules from so much height. The force is acting, the force is acting in this area. Force acting per area is nothing but pressure. Basically, there are gas molecules on the upper side on the atmosphere. They are on the above this lid, and they are acting in this area. So this force per unit area is nothing but atmospheric pressure. So there is atmospheric pressure acting in this direction. If you try to pull it in this direction, then you will know how much is the atmospheric pressure. If you try to move it in opposite direction, that you will know how much is the atmospheric pressure, but you can't move it, which means it is very, very heavy. Suppose, for example, if the area of my head were 15 into 15 centimeters, if your area of your head is 15 into 15 centimeters, how much force will air will exert on my head? How much force will air atmosphere will exert on you? How much air means the force due to air in a column of the height of atmosphere and area 15 20 centimeters nearly equal to the force of it. How much force is this? Means this force is equal to 225 kilograms, which is equal to 2250 newtons. What it is? 2250 newtons. It is too high. Really, if really this much force is applying on your head will burst. But it is not happening. Why means our the molecules in our head, in our skull also applying opposite force. For that reason we are not experiencing that much force. Okay, so basically we have completed chapter completed. We have explained all 10 topics. Now we are going to have a summary. Okay, force and pressure. In this chapter we have 10 topics. What are the topics? First topic is force. Force is nothing but a push or pull. In activities like picking, opening, closing, kicking, hitting, in all these activities we are pushing or pulling, which means we are applying force. Okay. Finally, what is push means? Force is push or pull. Next, forces are due to an interaction. In order to experience force, we need at least two objects. They must interact with each other, then only force will come into play. Two objects, they must interact with each other, then only force will come. What is the third topic? Exploring forces. Forces acting in same direction. Forces acting in same direction will add up. Forces acting in opposite direction will subtract. Net force is the difference of the forces in opposite direction. Net force is the sum of the forces in same direction. That is the third topic. What is the fourth topic? Force can change the state of motion. Force can change the state of motion. State of motion is, what is meant by state of motion? State of motion is the if speed changes, we state that state of motion is changed. If direction changes, we state that state of motion is changed. Okay, whenever speed change, state of motion is changed. Whenever direction change, state of motion is changed. Force can change speed. Example is football. Force can change direction. Example is this scale. So finally, force is changing the state of motion. Force can change the shape of an object. Yes, force can change the state of an object. By applying force, you can change the shape. Contact forces. In contact forces, we have muscular forces. Force due to the action of our muscles. Due to the action of our muscles, we are picking something, we are pushing something. So the force due to the action of our muscles is called contact for muscular forces. Friction forces. The force which is always acting in the opposite direction to the movement of the body. The force which comes between two surfaces is called frictional force, which is also contact force. Now, seventh topic is non-contact force. Non-contact force means even though there is a no contact between two interacting objects, force will come into play. Those forces are called non-contact forces. The first force is magnetic force. Magnetic force. Same poles of a magnet repel each other. Opposite poles of a magnet attract each other, even though there is no contact. And electrostatic force, even though no contact between these two stars, they are attracted. There is a pull effect we are observing due to the because charged body attracts uncharged body. There is no contact also. Next one is gravitational force. Every object which is thrown into the sky will attract towards the ground, but there is no contact between the ground and the objects. Next topic is pressure. Pressure is nothing but the force per unit area. Okay, next, what is does pressure exerted by liquids and gases? Yes, pressure liquids exerts pressure. We have seen with an example. And pressure at depth is same. Pressure at all points at same height is same. We have find out it using this example. Finally, atmospheric pressure. What is meant by atmosphere? Envelope of air is called atmosphere, and that air molecules exert force upon us. That is called atmospheric pressure. It is too high. Finally, chapter completed. Summary also completed. Don't forget to subscribe Sreenath for more videos for latest updates. So don't forget to subscribe Sreenath. Have a nice day. Bye.